Hello and welcome back. Today we're going to continue the glucose metabolism. We're going to focus today on the glycogen metabolism. So here we go. We, as well as the other times, we start with glucose. Glucose is converted into glucose 6-phosphate by the exokinase or glucokinase enzyme, as we already discussed in the other videos. Glucose 6-phosphate is then converted into glucose 1-phosphate, and the enzyme involved in this is, do you remember when you have this, when you just transfer a group from one carbon to another carbon of the same molecule? That's a mutate. So this is a phosphoglucose mutate. Once we have glucose 1-phosphate, you need to convert it into UDP glucose. How can we do that? Well, we need to start with UTP, which is another form of energy similar to ATP. UTP gets converted into UMP, so it loses 2 phosphate groups in the form of pyrophosphate, and then pyrophosphatase is going to break those down to create energy and 2 phosphate groups. But whatever, we have the UMP. UMP gets bind into carbon number 1, creating UDP, because we have 1 phosphate group here, another here, so we have UDP glucose. There is no number here because it is in the carbon number 1. UDP glucose is going to do something very cool. He's going to get bind to glycogen, which is a protein. UDP glucose get converted into glycogenin glucose until 8. Say, okay, so why do we have an 8 here? This is because we have only one glycogenin molecule and we have several UDP glucose molecules. But without any enzyme, we can put together 1 glycogenin and up to 8 UDP glucose together. But in the process, we lose the UDP. So in the end, we are getting molecule with the glycogenin and several glucose molecules up to 8 put together with an alpha 1,4 bond, which is one next to the other. Then the glycogen synthase enzyme keeps polymerizing and it creates branches of glucose alpha 1,4. So straight glucose branches. And then we get the branching enzyme. The branching enzyme cuts 7 of those glucose molecules and creates an alpha 1,6 bond. And that eventually creates glycogen. As you can see here, this is a structure of glycogen. This is glycogenin, and these are branches. For example, this is a branch of alpha 1,4, alpha 1,4, alpha 1,4, and here, as you can see, this is an alpha 1,6. An alpha 1,6, and here we have another alpha 1,4, alpha 1,4, alpha 1,4. Okay, so glycogen is this structure with glycogenin in the middle and all around it lots of branches of glucose molecules. And that's called glycogenesis. That's called glycogenesis. It happens in the fat state after we eat maybe some carbohydrates, maybe some bread, pasta, lasagna, something that spikes our insulin. And this process is allosterically regulated by the quantities of glucose 6-phosphate. If there is a lot of glucose 6-phosphate, this process is activated, it gets through this process. Okay, so now we're going to get into Glygogenolysis, the breakdown of glycogen. So, glycogen gets converted into branches of 4 glucose molecules. Okay, what is that? Here there is an enzyme called glycogen phosphorylase. What this enzyme does is to throw phosphate groups into the alpha 1,4 bonds, breaking them. And what it is releasing? Glucose 1-phosphate, because it's replacing the bond on the carbon 1 of the glucose with a phosphate. And this detaches the glucose from one another, breaking down the branches. And this glycogen phosphorylase can act until 4 glucose molecules from an alpha 1,6. So in this example here, the glycogen phosphorylase can act until 4 carbons from an alpha 1,6 bond. So in this case, here is an alpha 1,6. We count 1, 2, 3, 4. So until here, these molecules can be phosphorylated to break down the branch. So we are left with 4 molecules. And that's why here we have a branch of 4 glucose molecules. Then the debranching enzyme, what it does is it cuts the 3 remaining from the one with the alpha 1,6. Remember, we are left with 4. Then this enzyme, what it does is cutting those 3 extra, and it creates an alpha 1,4 bond in another branch. So for example, here, imagine 1, 2, 3, okay. These are gone by the previous step. Here we have 1, 2, 3. These are caught by the debranching enzyme and are put into this one, for example. So as you can see, you get rid of ramifications in this process. And then the alpha 1,6 enzyme, the alpha 1,6 bond, the glucose with the alpha 1,6 bond is broken down and free glucose is released. And then you get the final point where you have glucose available and you get with less glycogen. And those branches remaining, they have no ramifications. Okay, so the regulation of this process is by ATP. If there is too much ATP, glycogenolysis is not going to occur. If there is too much glucose 6-phosphate, it will stop glycogenolysis. Even glucose itself in the liver will stop glycogenolysis, and this happens in the fasting state, when we are not eating, when certain hormones are activated. So here we're going to look at first the glycogenesis. Glycogenesis, hormonal regulation. So we talked about that this happens when we eat in the fat state. So insulin, what it does is getting coupled with a receptor, a trypsin receptor, that activates the phosphoprotein phosphatases. What phosphoprotein phosphatase is, also called PPP, they steal the phosphates, because phosphatases steal phosphates. They steal the phosphates and they activate the glycogen synthase, because this enzyme has 2 forms, one activated and one inactivated. the activated one is without the phosphates. So basically it's stealing those phosphates to activate this glycogen synthase. At the same time, it's stealing the phosphates from another enzyme. We're going to get back to that. We're going to explain now how glycogenolysis is working, how the hormonal regulation of this is working. So here we have two steps, two pathways possible. It has to be an hyperglycemic hormone, which can be glucagon, epinephrine, norepinephrine, cortisol. And in this case, we're going to see first this one. The G protein activates an adenylyl cyclase that creates a CAMP, which is cyclic AMP, and cyclic AMP activates the protein kinase A. Protein kinase A has phosphates, and as a kinase gives phosphates to the phosphorylase kinase B. This is protein kinase A, phosphorylase kinase B, to convert it into the active form, which is phosphorylase kinase A. So activates it B to A, because this is the same enzyme, only that this is activated with the phosphates, and then the phosphorylase kinase A can activate the glycogen phosphorylase by giving it phosphates. So this enzyme is activated when it has phosphates. Okay, do you remember in the previous step here? Phosphoprotein phosphatases are removing phosphates. So at the same time that is activating the glycogen synthase, is deactivating the phosphorylase kinase A. So this process cannot occur at the same time. Another way to stimulate this glycogenolysis is by activating, well, the G protein gets the GQ. GQ binds to phospholipase C, which is a receptor on the membrane that stimulates the conversion of PIP2 into IP3 and deacylglycerol. IP3 can stimulate the exit of calcium from the endoplasmic reticulum. Once calcium leaves the endoplasmic reticulum, calcium activates and stimulates the conversion of phosphorylase kinase B into phosphorylase kinase A, activating then the glycogen phosphorylase enzyme. And this is how glycogen metabolism works. As you can see then, for example, we have free glucose that can leave the cell, and glucose 1-phosphate. Glucose 1-phosphate uses the same enzyme that used to be created from glucose 6-phosphate to create again glucose 6-phosphate, and then glucose 6-phosphate uses the glucose 6-phosphatase to get back to glucose, and glucose then can leave the cell. That occurs in the liver, the gluconeogenesis. The glycogenolysis and gluconeogenesis is similar. It's not the same, but is very, very similar, because they both want to get glucose outside the cell into the bloodstream to elevate glucose levels. Okay, so enough for today. The glucose metabolism is done. I hope you understood it well, hope it's helpful for you. I will leave this image in the description below so you can download it and study it very well. And I would really appreciate a feedback from you in the comments, and by hitting the like button and maybe sharing this video to those one who needs to know this for maybe a test, or they are studying, or they just want to know how metabolism works. And that's it. Hope you enjoy it.